Guys, good morning and welcome back. Welcome back to S4. Hope you guys had a lekker and you rested well this holiday. But I mean, don't have too much small talk. I'm not sure what's happening with results. We were all under the assumption that results were going to be published on Friday. I honestly have no idea. I did speak to HUD during the weekend. She was also under the assumption that the results would have been published. So obviously I'll follow that up through the course of the day. But the reason why I wanted to start today is because the better we start, the sooner we start, the better it will be for us. And also give you more time to absorb the content as well. And also next week, or this week rather, it's a long weekend. So Monday's lectures will essentially be cancelled. That's Women's Month, so that's Women's Day. Therefore, we can't have lectures on the day. So I don't want to waste 2 weeks of not lecturing, and you know how that normally ends up if you don't actually if you don't have enough time. So that's why I wanted to push for today. And then yeah, so okay, so let's just go through the list here. I'm gonna just slowly browse through it. If your name is not on here, that means you probably have to do a manual registration. Apparently, there's no limit to the amount of students registered, which is very unfortunate for me. But yeah, so I'll just quickly scroll through it. Obviously, you can contact the necessary people, the class chefs, maybe myself. Get a minimum form, you can add the subject. So yeah, I'm just gonna scroll just to show you easier. I'm gonna zoom up a bit. Okay. Sure you guys can see that. And also, guys, if you do not pass the subject, please deregister. It is of utmost importance. I'm gonna find you. You need the prerequisites and the materials too. Otherwise, you just end up failing again. So please deregister the subject if you haven't passed it. Is there any questions, by the way?
Yeah, sir, it's Alex here. Morning. What chapter did you say you wanted to start with today?
It's in chapter 1. You're going to see the trusses.
Okay.
Yeah, I don't know. It's a quick chapter. Okay, I'm scrolling. Yeah, I see all my students of this year and last year are here. Okay. Yeah, so this list will be cut down at least by 10, 15 students from what I can just see here. Okay, so we've got, as it stands, we've got around 64 students. So yeah. Okay. Is there any questions regarding to registration? While I am on this note, on this topic. Any questions, students?
Yeah, I think
Go for it.
I think I do see that I have been registered on the proof of registration, but I don't think I see on the list there that you have that. I don't see my name. I don't think.
Yeah, so the castle, I think I got this list on the 16th of July, and so if I download a new one, your name will probably appear on there.
Okay, perfect.
That makes sense.
Yeah.
Yeah. So, and the thing is, I was trying to download the latest list. However, yeah, like I said, I think my contract ended and they renewed it, and every time they do that, then they like reset your details and stuff. So it's a bit of a pain. Mr. Mzam doesn't see his name on here. Mr. Mzam, you better check on your proof of registration if you're on here, because I know you would have registered in the start of the year. I don't see it as well here. I'm not sure. Just have a look. Maybe a lot of people, these names are also very confusing. So maintenance engineering is the materials 2. Maintenance engineering 2. So please go have a look and just get back to me. Yeah, so just check that out there. All right. Okay, so let's move. Let's start with the lecture now. there's no other questions. Mr. Mzam, please just have a look. I am pretty sure that you probably didn't register the subject or something. Okay, guys, so, well, not shaded, there we go. We are starting officially. Unfortunately, I don't have to do any introductions. Everyone knows me, either through me lecturing them or maybe via reputation. As it stands now, so I don't have to do any formal introduction myself. Yeah, anyway, guys, just obviously some guys are aware of this. We're gonna have online lectures through the Blackboard Collaborate program software. And the title is synchronous and asynchronous. Normally, synchronous essentially means as per timetable slots, and asynchronous maybe might have an extra lesson recorded for you, then you still have to watch that. But normally I stick to the synchronous thing. I prefer that. I don't like to just leave recorded lessons, or like, I record pre-record. But if I have to, I will. The link was normally sent to you via Blackboard announcements around 15 to 30 minutes before, so you can join before. And also on-campus lectures, also under discussion. It's always going to be under discussion, and it's depending on the lockdown level. So anything on campus for now, I'm pretty sure we still have on-campus assessments. It worked very well the previous semester. Yeah, so yeah, it's always going to be on-campus assessment. So that's why I mentioned for anyone on C, it's a bit tricky, because at the end of the day, you're going to have to write your final on campus. I might have a lot of leeway with your tests, but when you're going to sit down, you're going to sit down the exam. There's no negotiations about that. Also, you have access to all the sessions after the lectures, or recorded sessions. So whatever we've discussed today, you have it there. Someone will just always remind me, like, the extra function you can click so I can actually download the lectures. Don't have to, but some people, especially on board, don't have good Wi-Fi signal, so they can't really stream. So then they have to re-download the lecture. Some of them actually compress it, and so I can rewatch it. It's worked quite well the previous year. So just making you guys aware that it's there. Okay, guys, this is the timetable as it stands. So we have strengths on Monday. Well, definitely from 8:30 till 11:40. Only once a week. Well, once a week, twice a week, 4 periods. Right. I just got an email from Dr. Lambert now, and he's talking about swapping Tuesdays for Wednesdays for a period of time. So I think what might happen with this timetable is that things might be switched up a bit, the Wednesdays and Tuesdays particular. So maybe everything will just essentially be swapped. Like, how do I say? What's it, 6 periods will just be replaced by another. So instead of you having your technical subjects on the Tuesdays, it might be on a Wednesday as well. So just making you guys aware. So just for the mechanical subject, obviously I'm the guy responsible for that as it stands for all of them for now. There's strengths on the Monday, we have electros afterwards, 2 periods, another 2 periods on Tuesday, or maybe it's going to be Wednesday now. And then we have moms as well, which I'm also responsible for. And then on Fridays we have thermal. So yeah, there isn't a lot of things scheduled for like tutorial sessions and stuff. So my lecturing approach, obviously my students will be, I try to do as much examples here during the lecture as means of instruction, to kind of play around with some numbers and see, to get understanding, but you have to put in the hours. Yeah, is there any questions on the timetable before I actually go on to the sections covered and what's required? You can just raise your hand if you need a question, or just say something. Is there any questions, students? You just type no in the chat, maybe. See more students joining over here. Good morning. Welcome to S4, guys. Oh, Miss Jackie's here as well. Who else is here? Leroy. Yeah. Mzamush here. Okay, guys. Is there no feedback? No questions? Cool. Next. So, should I actually? No. I think we should start over here. Guys, previous card textbook, exactly the same textbook. Fortunately for Strength for Materials 2, that's the one you want to get. It should be Advanced Kite, Balvo. Please come by here to the engineering campus. I've also got 2 recommended textbooks, which I'll steal a few things from, which I'll also share with you. I've shared a few notes with my students. It's S.S. Rattan and Dr. R.K. Banzo Strength for Materials. So very good textbooks. I prefer those 2 compared to, well, the Trotsky one. There's a reason why I actually recommend them. So I'm assuming everyone has these textbooks. Maybe once you also contact previous students who've passed, get the textbook probably for cheaper. At least I want to keep it for any sentiment. Let me just quickly see here. See, O'Neill is trying to join you. Okay, cool. You guys are aware of that. And then topics will be coming. Let's go over here. 3D trusses, using tension coefficients, temperature stresses, strain energy, second moment of area, theory of bending and bending in beams, which is essentially part of the same thing, you'll see. Shear stress in beams, deflection of beams, and struts. That's around 8 sections to cover. You're going to spend around 2 weeks per section. In fact, to be honest, it's more like 1 week per session. So 1 week per chapter for students. Certain things will take longer, but obviously I know when to kind of extend the thing. So treat it as 1 week per section. I do see us finishing up strengths before. Strengths in letters will probably finish up much more quicker. Just depending on how we go. But obviously I have to pick up. I have to see how the pace and if you guys are learning. But I'm pushing for 1 chapter a week, which would be very ideal for us. But I know from bending to struts, it might go 2 weeks per chapter. But you'll see. Yeah. Okay, guys, please get this calculator. They should really start. They should really start paying me for this. I should really become an endorser with this calculator. I promise you. You need this Casio or something equivalent to this. I don't know what's the equivalent sharp version again, but guys, this is you need this. You need this for the subject. Otherwise, you're going to end up trapping yourself. I don't say trapping yourself. You're going to end up doing lots of hard math for no reasons. And I essentially assess you on your analysis versus the mathematical approach. Obviously, you get marked for maths, but you guys get the idea. So, any questions till now with this calculator? And obviously, most of my students are here. There are some new people as well. So, I think it's around $500 to $600. I'm speaking heavy under correction here, but yeah. Any questions? Dan was also on short, Mr. Mark. Guys, are you still there?
Following along.
Yeah, following along.
Thank you. Yeah. It's all good. Thank you, guys. Thank you. Right, guys. I wish I could really say this each lecture. And I think I've got some good students here. Maybe I would like the guys who scored very good marks. Maybe I'd probably like them to share something. But guys, let me just I really want to don't talk more than 5 minutes or 3 minutes on this particular slide. And what it is, what is expected by you, what is your responsibility. This I'll probably say in each of all the subjects. And guys, please don't sit and watch my lectures. Obviously, it's the time where I talk and I explain something. But when we're solving a problem, I highly recommend you solve it with me. so that you kind of get into the flow of solve the problem, you know, like take notes, whatever you find useful, and solve examples, what I say, during lectures. So obviously you'll see as we go along, we're solving examples. Don't just sit and watch me. There's really no point. This subject doesn't work well with just not being active. It's not a theoretical subject. There might be things I might ask you, which essentially free mark some theoretical questions, but predominantly, and talk about 90% of it, it's just going to be, it's just numerical type problems. Second thing, ask questions. Please, guys, you know, I always try to answer as much questions as possible, especially during the lectures. Even on WhatsApp, you know, I always attend to as much questions as possible. Please ask questions. It's the reason why you pay your school fees. This is the reason why I'm here. I don't like I always, I don't need any fog in your mind. I'm here to remove the fog. So ask the questions. It's good for all of us. It's good for myself. Just in case I've missed something, it's good for you. And questions is a sign of I would say, critical thinking, that you actually are thinking about the problem correctly. Okay, and then complete all exercises in the notepad, or in this case, it's going to be textbook. So guys, it goes without saying, try to complete all the exercises. Probably not all of them. Some of them are really over the top. But please, please, please. The approach of attempting the exercises is there are two reasons why you want to do it. The first reason is to test your understanding. So I teach you a concept, you learn the concept, and you apply the concept. That's the way you must approach it. Don't go there and go solve all the problems and try to remember. It doesn't work like that. You are learning a concept and you're seeing, okay, this concept will fit for these particular problems. And it should, obviously. That's the way it's designed. So please try to complete as much. I would really say 80% of the exercises. And there's a reason why I say 80% or maybe even 70%. Obviously, I give you extra tutorials as well, which you need to account for. Another thing is complete all tutorials per lecture instruction. So I don't have formal tutorials, but I do share a lot of my extra notes. And I always say, guys, this is the note you should focus on. Right? I use a textbook as a form of just to facilitate the work. But there's always extra things which I like, you know. Just, okay, try this one, you know, might come in the test, or this looks, you'd see a nice problem, you know, and try to do all of that as well. Okay, and also complete all past papers as per lecture instructions. Obviously, I'll be uploading some past papers or some tests which are there. But essentially, I'm more really focused on tutorials and exercises and the lectures. That'll be really how your exam looks. I'm also rewatch the lectures as many times as possible. There you go, watch it over and over. It's recorded, it's there for you. Watch it, come back to me. So it's not clear. I really like when my students send me a WhatsApp small video. So your time explain this. Obviously, I've tried to attend to it. It's going to be a bit tricky now because I have like so much subjects, but I'll try my best to answer that. Also, guys, we have YouTube and Google essentially. Watch videos if you don't understand. If I'm explaining poorly, you've got other sources or other teachers to help you. I think I'm explaining fairly okay. So you should be able to understand me. Yeah, watch as much videos as possible. I normally might send a video too, just to really, you know, it was quite nice with moms where some people didn't grasp the way I did the relative velocity chapter, and they watch some videos and they do their own approach and they get the marks for that. I'm open to that, so that's quite nice as well. Also, this is another thing which kills people the most, is the study schedule thing. Please have a rigid study schedule. I don't know if people want to share maybe some tips on this, but it's all about disciplines, all about habits. We're creatures of habit. Don't study when you feel like studying. Just have a good schedule. But of course, within that, you can further bifurcate exactly what one must do. But the point is, you have to be studying every day. Monday to Friday, it's work. You can rest the weekend. You can have a beer on the Friday, you can rest the Saturday, get back on the Sunday. It's only for a short amount of time. After this, you can put all your theory subjects behind you and you can go on C, make the money, start your life, build your career up. So please, guys, the study schedule is key. The study schedule is key. Make it a habit. Is there any questions around this or any tips other students wanna say anything? Or should I pick you out over here? Good morning, Unira. Yes, go for it.
Yeah, so I'm not sure if it's too early in the lecture or in the, but have you planned a specific date for the first test at all?
How would you like basically? I haven't planned a date, but how you know we're getting close is once we reach chapter 4. And I'll go there now. You know, we can have a test like probably 2 weeks from then.
All right.
The problem with yeah, it's a good question. The problem with me not having the dates is that the faculty hasn't actually released the term like the scheduled dates and stuff. So particularly the final exam dates. So we will not worry about that. But the place that I go, I would know that okay, in 2 weeks' time you guys are taking the test. So I can roughly tell you. Looking at it now, your first test, was if your holiday is still apparently from the 3rd or the 13th, is that you have like a week holiday.
All right.
You might probably write the first week you guys get back, so, like which is the 14th or the 13th. That's the Monday. You might write on the 13th, so that you basically have holiday. That's like from what I can tell you. Unless alternatively, you might write in the last week, which will be the 30th of August. So I have an idea, obviously, but one must be a bit flexible. Yeah.
Yeah, I understand. But is the varsity still trying to push for exams in November, or do you think they'll go into December?
No, it's going to be November. They always push for the best, but then they always might change it eventually. That happened last. It depends on the COVID thing, man.
Yeah, I know.
But yeah, what happened with this wave, yeah. No, it's going to be November. Like they keep it as under normal conditions, and then they'll just change it. And like, oh well, you've got to readjust now. That happens. I'm so used to it now.
All right, thanks, God. That's all.
Cool. Yeah. Okay. So guys, please, this slide here, it's so small, so little. What's a bit of text, but please, man, keep the momentum going. Don't just. You need to study every day. Yep. So this is back to this is what Alex was kind of leading into. This is essentially the strategy assessments I'm going for. Straightforward approach. Reason being, just got so many subjects really. And of course you guys are used to it. Well, it's 50-50 and 100 should mean that's the way you guys call it. So how are we going to basically gauge this? Let me just quickly go back to this. I just want to fix this so I can be at peace with myself. How we know we basically going to get the first test. This might not be necessarily true. Yeah, we look like that, something like that. Once we start that 4th chapter, just know that you'll be writing in 2 or 3 weeks. That's one thing I can tell. That's the first test to read. So our normally set assessments, it's the first 4 chapters will be the first you'll be firstly assessed on that. And then the second test you'll be assessed on the next 3 chapters. And then the last section will normally be assessed only in the final. Is that all clear to everyone? So normally got to keep around 7 to 8 sections. Is that clear? So for the first 4 chapters, the first test, the next 3 chapters, should actually write it here. The next 3 tests, the next test will be the next 3 chapters, and then the final will be all chapters. But what I normally do for you guys in the final, I try to create a selection kind of setup in the final. It depends on my mood, so that you don't have to cover all chapters. And a lot of students have problem with the session and say, guys, obviously you want the best marks, but just push for 50. Make sure you study hard enough just to get the 50. Because 50% is a pass, 51% is a distinction, and 52% is neglecting your family and friends. So please. Yeah, so I hope this is clear to everyone. So I think, Alex, I can't give you any dates yet, but yeah, this is as it stands. Any questions around this before we start the actual lecture? Can I proceed? Someone's just typing a question. Sasha, got a question? Alex?
No, it's fine. You can
No, I'm all
proceed.
good, thank you.
Okay, fantastic. Okay. All right, guys. So I'm gonna give you guys like 2-3 minutes. Just get the textbooks ready, your notepad or whatever you have, your calculator, and we'll start on. So what are we starting on? Let me just direct you quickly. If you have a textbook, that's page 10. Well, we're not really 10, yeah, I would say 10. Or not 10 particularly, but I mean 13 or 14. So yeah. Cool. So just yeah. No, the fees will not be online, John. It will be on campus. On campus. All assessments are on campus. So I should probably write this here. I'm not going to tell you why we've decided this. You guys can figure that out. All assessments are on campus. So you guys want to grab a coffee, you might as well just do that now. No? You have enough time. This is a quick chapter, guys. It's not a big chapter. You'll see. I just tried to make it fun. Yeah. So we will finish the chapter. It's very short. Fact strength is very short. So you do not worry. All you need to do is go back home and put in work. Okay, guys. Yeah. I'll start at 22. Yeah, that's okay. Just get your stuff ready. So yeah. I'll just leave it here for now, and then I'll see you guys now. There are no arrangements for students at sea, John. I just clearly stated now. Your final exam is on campus. If you're on sea, I can negotiate with your tests and stuff, but the exam is basically on campus. So yeah, so it's a test. It's negotiable. And then it's fine if you're on sea, but your final, you're gonna have to be here. Is it clear? All right, let's begin. John, I hope you got my question over there. Students, are we all here? Can we proceed?
Yeah, sorted.
Okay, fantastic. Okay, so chapter we're starting on, or chapters, obviously part of chapter 1, but these are under the 3D truss section, or what we call a 3D truss. In other words, also simple space truss. Just quickly go over what this is. So a space truss is a three-dimensional structure, yes, and the most stable space truss basically consists of 6 members and forms a tetrahedron. That's like the most simple basic form. It's not really of particular importance. I'll just got a small message here. Oh, fantastic. Okay, thanks. Great thumbs up. And also, saying a simple space truss can be constructed by successive addition of 3 members to a joint. And the same computers are normally employed to solve the force in the members and the deflection of the joints because the extent of calculation involved. Yes, because you have around maybe 12, 10 unknowns. So we have like 10 equations, 10 unknowns. So therefore, obviously solving it by hand is a bit tedious. Or not a bit tedious, yeah, it's a bit extensive. It's not difficult, but yeah, it's a bit of a mission essentially. So let's say in the next paragraphs, a graphical analytical method will be used to solve space trusses. Fortunately for trusses, I am not particularly looking at any graphical methods. I don't particularly like graphical methods. However, in MOMS, graphical method, there will be a lot of graphical methods happening. So yeah, just give me a second. Yes, thank you. Thank you for your patience. Yes, so yeah. So what we'll be essentially looking at is analytical methods for 3D trusses, right? Okay, let's move on. So, where have you seen 3D trusses before? I'm sure you've seen it around, right? Guys, what are these structures over here? Someone tell me. What are they called?
Gantries.
Gantries. Yep. What are they used for?
Removing and
Hoisting.
adding containers and cargo to ships.
Yeah, basically, yeah, that's what it means. It's a crane essentially, and those members over there, I guess I'm not sure exactly what the vertical member is, so the horizontal one, and essentially supports it supports that. These are real life 3D trusses. Of course, you've all probably seen this as well. And yeah, I'm just showing you a few 3D trusses in a more in a real life fashion. So basically what we'll be looking at is analyzing the forces in the members and also applying, my special taste of seeing when things will fail or not fail. Of course, within its own realm. It's not 100% accurate, but it gives a good indication of, you'll see, obviously. Okay, so there are various methods to solve spray trusses. The graphical methods, like I said, we won't be covering. There's method of sections and method of joins. So I would like to show you method of joins for 3D trusses, maybe in the next session before we start. But I won't essentially assess you on, but you can use method of section and joins for 3D trusses. The final element technique, which is the most efficient and modern. Of course, that's you have to do it by a computer. You construct a 3D model, you apply your boundary conditions and go through a specific element. This is normally taught at a BTEC level. The final element technique, it's the more modern way of doing it. Any solid mechanics. Just gotta email and use the team. This is what my access here. To you before. Thank you. Yeah, but the method for this subject will be tension coefficients, or rather the method you'd be assessed on is using this method. Okay, it's fairly quick to do. It's nice. Okay, so yeah, this is just kind of recapping on this thing. And the methods I talked about, normally for simple space truss, obviously, we've got method of choice, which is all our favorite method. And what we basically do is we assume that the structure is in equilibrium, therefore our forces in the horizontal and vertical direction is zero, and then we can obviously conduct analysis of it to find the forces within the members. We've got also method of sections as well, not everyone's favorite. Basically you section off a portion of the truss, and then you basically can take moments at any particular joint. Yeah, so these two are essentially what's covered in strength of materials too, right? One must also view strength of materials 3 or maintenance engineering 2 as extension of strength of materials 2, but it is a bit more challenging solely due to what's like an NQF level 6 subject, so it's like a final subject. So it's not like plug and play. You got to do a bit of thinking. Yeah, for this level of all my subjects. It's not small. It's mostly plug and play, 50% plug and play, but the rest is a few spins. But it's more for understanding purposes. And of course, there's a space truss, and yeah, we're gonna just essentially use tension coefficients. I like what they say over there. It's probably a bit small for you, but it says the joints are assumed to be ball and socket connections. Most important of these trusses that we assume is they are pin jointed, and normally we only allow the forces to be on those joints. That's the analysis we do. If you have your force anywhere in between those, it really changes up the analysis. Well, it's not as easy. You've got a few things happening, bending and you've got a combination of different kinds of loads occurring. Right. So what is tension coefficients? How do we actually go about it? So this is on page 13 in your textbook. I'll explain. So what we assume there is a member, right? So it doesn't really matter what it is. You get the hang of it. So let me just exit this and just kind of so I can write on the actual slide. Hope it'll be okay for everyone. Let me just have a look on Blackboard. Okay, yeah. So page 13. Change my color up a bit. So this over here is a member. So in figure 1.19, we consider member AB. So this is obviously any member. This member looks like it's in tension. Was it in compression? Well, it's actually in tension because this is the internal forces acting that way. So it's actually, of course, I've discussed this in the previous stance. So what happens is, what we need to do, what essentially do, we are resolving. We have basically resolved this in the x and the y direction. So of course, this will be the x1, FAB cos, right? You guys are aware of resolving components, and also FAB sine theta. So that obviously this will be the resultant. So we've got a force here, now all resolved here. Now, what they actually do is that because we're dealing with obviously a coordinate plane here, now a x and a y, right? Because these members have a specific length, right? And of course, this is related to the coordinates x and y. We just essentially replace cos theta with the change in x, which is obviously going to be your adjacent side over the hypotenuse, which is x delta x divided by LAB. And of course, it is exactly the same for sine, which will be delta y over LAB. So guys, don't worry. I don't always push on developing, but I'm just quickly showing what a tension coefficient is. It's not that long. And then basically what a tension coefficient is, and it says it's obviously the coefficient. What we essentially do is we define the tension coefficient of AB as the force in the member divided by the length, right? And if based on that two equations over there, we know that the length of the member, LAB, what is LAB? So the force in the x direction is that. So let me just write this out for you. So LAB times. Okay, let me just get this. Oh, flip! I didn't actually program my button here. It's going to be a mission to not keep on deleting. So I'll just get back to this here. Just keep this over here. Make my color a bit thicker. Right, so here we have F AB, right, equals delta x over LAB. Okay. So then so what they're saying here is that the tension coefficient is TAB is FAB divided by LAB. And all what we're doing really is substituting this LAB counterpart over here, this part over here into here, and we end up with the force will be some tension coefficient AB times delta X, some that's for the X direction, and then obviously for the Y direction, exactly the same thing. Just very basic substitution. So what's also important to note over here, so I just have to now really delete this, is that with this method, the third dimension can be easily accommodated, but the component of for FAB in the Z direction is 0 in this case, obviously because we don't have an X and Y Z plane, but you will obviously see. And what's cool of this is that the use of angles to calculate components of force has been totally eliminated. What it really does is that you don't have to worry about, cos 30, sine 30. So we just essentially use the ratios of its position to its length. Sounds a bit vague, don't worry, it's very simple. And then also the sign convention is basically we assume tensile forces are positive, compressive forces are negative as per normal, and the assumed part directions of X and Y, Z-axis must be indicated. Okay, right. Just a quick recap on that. X this way is positive. Okay, this one is the spin is a bit too thick. Okay, so let's change up the color here. Obviously that's positive, that's negative, that's positive, that's negative. And if you're dealing with a Z-axis going that way, that's going to be deemed positive. Let me just get it. I just chose the wrong pin now. And to reprogram my buttons here, guys. Sorry about this. So I can quickly edit as I go along. So where's my red pin? Just going that way. That's some of this blue one I chose. Okay. Yep, there we go. Nothing back to blue. So this is going to be positive. That's going to be positive over here. That's obviously negative. Obviously negative. Negative. You see the idea. All right. Okay. So obviously, so a length for a two-dimensional member. Obviously, you guys are aware of the distance formula. This is the distance formula you were taught in geometry during grade 12. And how we essentially find the length of a three-dimensional member is nearly the same. So you're going to have x squared plus y squared plus z squared. That's in your textbook, but a lot of obviously students haven't done three-dimensional vectors and stuff like that. So just a small thing to note. It's not a really big thing. But essentially, it's how you're going to find the length of the member in the actual thing. Okay, guys. So we're going to start on an official first example for S4. So let me just get my whiteboard ready here, so I can start the actual example. Okay. Copy this and then paste it. Now, some students will be a bit new to this now. So I'm just going to reshare my screen now. But on a whiteboard, so I can actually write. Is there any questions thus far? Students? Questions?
What example is that? Is it 1.5, a diagram?
This is 1.6. Oh, yeah, this is 1.6 now. Yeah.
Oh, okay.
Cool. This is example 1.6. I'll write it now. Okay. So we have a blackboard here. But I'm using a whiteboard in this case. So I probably should use a red pen. Example 1.6. Okay, so the question always states, what do you really want to do here, guys? Is just basically find the forces in these members. What's important to do this is obviously identify your axes over here. So it's normally given to you, but obviously you can also sometimes you have to kind of just create your own axes, but normally it's given to you. So, and what I mean by this over here, this guy over here, obviously this is a old sketch. You guys have a lot better sketches in the textbook. That is y, that's the y-axis, right? The blue is the x-axis, and of course as it's going up, that's the z-axis. So I hope you guys can all see that, right? Are we all happy with that? Okay, I guess we are.
Yeah,
So
yeah.
just yeah, should be straightforward. Just erase all of this. Okay, so the first thing we do normally, what we're going to do is find the sum of the forces in the x direction. I'll leave it blank there. Sum of the forces in the y direction, and sum of the forces in the z direction. Of course, you can apply this first law of equilibrium, static equilibrium. So yeah, so now what I normally like to do is actually just get my coordinates for each member. So we have 3 members here. So it's A, D. That's my first member. My next member is CD. And my other member is PD. Can we all see that?
Sir,
Yes, go for it.
what about AE? Is it not a member?
AE. No, it's not.
All right.
Yeah, that's I don't know why they call it E. Yeah, I see it's not on the actual yeah, it's not a member, yeah. It's just it looks like a member, but it's not. If you look at the actual example, I don't know why they have an AE there. It's quite strange. Yeah. I can see why you think that, yeah. But it's just 3 members actually. That's so don't worry too much.
Okay,
It's
thank
just
you.
3 members. Yeah. But thank you for raising that. Okay. Where am I now? So let's go to the board. So if we look at member A, right? So I'm plotting this in terms of X, Y, and Z, right? X, Y, Z. That's a standard 3-dimensional Cartesian plane. So in the X direction, member AD, or this point A rather, point A, I'll just have A here. This is going from 0 point, that's -3. With forces, I'm assuming you guys are picking up, and that's 1. And in the Z direction, it's going to be, if I look at it, starting from there to there, it's going to be 5. If it's 5, is it positive 5 or -5? I think that's a -5. Are we all happy with that? Are we all happy with coordinate A?
Okay.
-3. This is the 0 point. And it's going to be positive 1. That's on this point here, and then this will be -5.
Okay, I'm with you.
Yeah. So can we you can see the reason why I'm doing it. It's going to be easier when we do the tension coefficients, man. So it's just going to be easy, just like you'll get it. Let's try B. What is the coordinate of B?
Sir, sorry.
Yeah.
I'm happy with -3 and 1 with the -5. I understand that's the Z coordinate, but I'm not sure
Yeah.
how you get -5.
So remember what I said, like. That's
Oh,
how I get
sorry.
that.
Are you treating point D as the 0 point?
No, here's the 0 point. There.
Sorry, where?
Just over there. It says 0 there.
Yeah.
For
Okay.
the origin.
Yeah, I can see that.
So let me just erase that. All this here. So the reason why it's -5, remember I mentioned like with the axes that we get X, Y, Z, like that. That's positive, that's negative. Yeah. So this is negative on the side here. That's positive there. You'll get a hang of it. Don't worry, it's looking complicated, but it's not. You'll see. You'll see. Flipping over. Oh, okay. Just a notification. Yeah, so can we just get B quickly? Can someone read it out to me? Weekly.
B would be 2, 2, and then minus 5 as well, sir.
I agree. That's yep. That's going from it. That's 2. Yep. 2, 2, and beautiful, beautiful. Love it, love it. See. What do you see?
-3.
-3. Yeah, I can hear you whisper there. That's good. Is it -3? No, it can't be -3. It's not.
No, it's not. I think it's
Yep.
minus 1.
No, it's on this axis, so it's
Min-
0. It's on this. There is no x coordinate. Yeah, 0, -3, and -5. That's it. There we go. The textbook should have better sketches. I don't think I have this scan in this particular. Perhaps I can draw it SolidWorks or something. 0, -3. Yeah, there we go. Okay. Why the 0? There's no x coordinates exactly on the y-axis over here. So if you are. All right, guys. So what we do now, we're normally just gonna have to. So once you have a coordinates, it's gonna be really easy. So we normally write it. The members like in a particular order. So TAD, TAB. Sorry, TAB, TBD. I think someone's mic is on. I think it's Mr. Talk, or is it Alex's mic? Is it muting now? Cool. That's fine. Let me just erase this a bit messy over here. Okay. So TAB, TBD, and what's the CD? Okay. Yes. Grandson.
Sir, please explain for me for coordinate B, how did you get that -5?
Yeah, so guys, remember they're all going to be -5 in this case. Can you not see it? Let me just get back. They're all 5 away from here. There. They're all coming from that same point base over there. If this truss was on the other side, that would have been +5 on the other end. If it was going that way up. If that makes sense. If the members are all reaching to that point there. That's the Z coordinate of that point. You'll see it. Don't stress. You'll see it. We'll do a few examples. Yeah.
Yeah, sorry, so like me, intuitively, I would say the Z would be 0 because I'm still not sure why it's -5.
You see, the thing is, you can treat this as a 0 point and going the other way. I'm just kind of following the train of thought. You'll see it in the next example. You not have to worry. Like,
Okay.
yeah, the thing is, obviously, ideally, I want to focus on finding all the coordinates first for a few examples and then actually applying it, but I'm just kind of doing it all together. And once you see it, you're like, oh, it's not that difficult. We've got a few examples to practice. You'll see. It all makes sense. Do not worry. Trust me when I say do not worry. Yeah, you just have to kind of follow through with it. As long as you understand that that's -5 at that point, I can see why you guys are confused, but just don't worry. So we have the 3 coefficients or the 3 forces, or the tension coefficients. So we have AD, BD, CD. We don't want to keep it obviously in alphabetical order. So all we have to do is essentially apply. Let me just write it again here. Show you the exact idea. So it's TAD, TBD. I'm just kind of breaking this down for you so you can actually see. Where we're going with this is we're going to end up with a 3x3 matrix, right? So after this problem, we have a short break and we'll get back to you. So I'm letting you know. So the x coordinate for TAD, what was it? I'll write my coefficients in blue. What was it? Grandson Zam. So the x coordinate for TAD. Anyone? It's -3. Right? The x coordinate for TBD, what was it? 2. That's +2. And for CD, do you have an x coordinate? I think no. So that's plus 0. What we do now, of course, we have to make this equal to 0. Are we all happy with that? Do you see what I did there? So that's all the x values, the coordinate x values of the of the coordinate. So it's 3.
It's clear, sir.
2. Yeah, there we go. Fantastic. Okay. I'll get back to, I'm making them all equal to 0 for now. Then we look at the y direction. What do we have now? For TAD, it's going to be 1. That's why I talked about the coordinates. For B, plus 2. And for C, we've got minus 3. Are you happy with that? Right? And for all the coordinates, normally you're going to find the z's are normally all the same. So we can have minus 5, and minus 5. All equal to 0. Right? Are we all happy with this? Yes, Zach. I'm getting there. Yeah. I'm getting there. Are we all happy with this?
Yes, sir, so far.
Fantastic. So now Zach has raised the next question. Obviously, I'm kind of following the example step by step here. We have to look at the forces being applied on the 3D truss, right? The space truss. And if you have a look, you're lucky this time around, you got one force. You can have multiple forces acting on this thing. You can have 10, 3, you can have in the X, Y, and the Z direction. So obviously, if you look here, where is that force applied? It's applied in the Y direction over there, right? So that's going to be that's going to be 10 kilonewtons, right? So 10 kilonewtons. There we go. Don't forget the kilonewtons. Very important. A lot of students do forget. Or we can just keep it as 10. It'll be fine because the answers will come out in kilonewtons. And the sense of that force, that's what's important now. It's negative 10, guys. Negative 10, not a positive 10, a negative 10. Right? We're just going downwards. Right? We've deemed that as negative. And by the way, how you get marks? You get a mark here, you get a mark here, and you get a mark here. These questions normally go from 10 to 15 marks. Quick marks to get, and you'll see why. Or you might get 2 marks for each of these equations, but it just depends. Okay, we're all happy with setting up our equilibrium equations. A ball jointed truss, 3D truss. We're all happy with this? Question? Alex?
Yeah, so just with the truss, the first thing you do is you just find out your coordinates for all your.
That's correct.
Basically all your joints, and then you just sort out your equilibrium equations first. Okay.
Yeah, that's it. Okay. So now, some of you guys are not experienced with your 3x3 matrices, but obviously, you know me. I always sort you guys out nicely. Yep. Question. Is this Leroy speaking or Alex?
So, I guess, like the way I see it now, minus 3 is in a direction with 10 kilonewtons in one direction. They're going down. So that's negative.
Yeah.
Both of them.
That is correct. Yeah.
Yes.
Yeah.
So,
10.
Yeah. Oh, it's 10. Oh, okay. I thought like this minus 10 is supposed to be within the equation, and then when you equal it, it must be equal to 0.
Yeah, that is correct. Yeah. So what I'm doing here is you can say this is. Let me just recap on this. No, you're fine. You're fine. I could have said plus 10 equals 0, and I just carry it over. You see?
All right.
Oh, whoa. No. I see what you're
It's
saying.
supposed to be minus 10.
Yeah. My bad. It's minus 10 here. That's correct. Yeah. That's my mistake here. Okay. So it's minus 10, and then we carry it over, it becomes positive 10. Thank you for picking it up. That'll put me in another place. Yeah. So it's minus 10, and then we carry it over. Thank you. So be aware of that. Yeah. So the sign essentially changes over here. Thank you. It should be 10 there. Yeah. Okay. So once we have that, guys, right? Thank you for that. That was going to kill me. Sorry, I just missed that. What we're going to do is open up a matrix, a 3 by 3 matrix, right? Hey, so messy. Sort out my pen here, man. Right. Just for your coefficients here, it's -3, 2, 0, 1. Obviously, I expect you guys to write the matrix. I've told you this before. So what I'm just doing is essentially adding all the coefficients over here. Okay. So this will be either TAD. TAD's coordinates is -3, 1, and -5. TBD, TCD. And of course, this is what we're looking for. And we all make an equal, so of course it's equal to 0. Grandson says that is a 10, and this is another 0. Are we clear how to set up this matrix? Are we all clear?
Yeah, it should be good.
Okay, fantastic. Okay, yeah. So then, okay, you guys have to read it to me. So what's next is we're gonna have to I have to share my Codio calculator, which I'll share now. Boom. Do you guys have my calculator shared? You see him?
Yes, sir.
You guys can see him? Yep.
Yeah.
So you want to go to mode? Right, a lot of my students, I've taught them good matrices habits. You go to number 5, and then you're gonna have to. No, whoa, I'm lying. Sorry, let me go back. Hey, so mode, equation. What am I doing? Equation. Sorry, and then number 2. So number 1 will solve a 2 by 2 matrix, and I'll show you how to play around with that. And of course, we're going to number 3. So it's 3 equations, 3 unknowns. Oh no, what am I pressing here? I'm not used to. Okay, so can you see I have A, B, C, D? Are we all happy with that? So we just got to throw in our coefficient just like in the matrix, right? So it's -3. Oh, what is the first one? -3, right? It's 2, 0, and that equals 0. Is that correct, students? Make sure this is right.
Yes, it's right.
The second, thank you. For the second one, thanks. It's going to be 1, I think. 2 must be in the right form. And then -3. And of course, we've established that equals to 10. Right? Number 3, we go -5. -3 for the third line, -5. -5. That's the matrix. And that's also equal to 0, right?
Yeah.
Okay. We just go equal. And our first answer, which is TAD, is equal to 20 over 23. Does that correspond with the book? TBC is going to be 30 over 23. And TCD is going to be -50 over 23. Are we all happy with that? It's the time for questions. Welcome to S4. Welcome. Questions, students? Students, please, if you do not understand this, please tell me now. Let me just get this right here. Just want to sort out my stuff here.
So I think I'm quite happy with it, but the book doesn't seem to be.
Why? What's the book's answers?
Oh, this is forces in X directions and stuff, right? This is the forces in X and forces in Y and forces in Z, right?
No, these are the tension coefficients, not the force.
Oh, these are the tension coefficients. Okay, thank you.
Yes, n small t. Yeah. So I think the first one was. Let me just check my calculator again. What was it? I'm assuming everyone has done this with me, like plug and play, and not just watch me do this. And I think the other one was 30 over 23. And the other one was, what's the other one again? 30 over 23, yeah. But negative. Okay. Who is all here? Let me just engage with you guys. Botano, are you fine? I'm not sure what GD is. Mr. Gumede. What happened to my calculator? It just decided to run away. Okay. Oh, Loazi. Mugao. Putaung. Oh, Nicolines as well. So is there any question, guys, for this? Yes, we are still falling fine. Okay, right. So I'm gonna go back to my board over there. And we've got our tension coefficients, right? Let me see who else is. I'm going to check who's all here at the back. Ms. Jack, are you fine? Mr. Engelbrecht, you're not saying anything. Yes, Fusiwe. Who's this here? Oh. Fusiwe. Okay, not saying anything. Just got excited. Kamsanga. Where are you? Okay. There's no one wants to talk to me today. It's perfectly fine. So remember, guys, back to the formal definition of a tension coefficient, right? So the way we're going to find out forces is a force in a particular member will be your tension coefficient times your change in x, right? Or rather, it's just going to be a quick way. It's just going to be force AB rather AD, or any force, obviously, and that's just going to be your length times your tension coefficient. Of course, if you look at the units, it all makes sense because this is, of course, I don't expect any units for tension coefficients. So, for instance, like this.
Oh, sorry, sir. I was having a problem with my mic. It's
Oh, how's the chief?
Yes, sir. I'm a little confused when it comes to the signs, like -3 and.
Okay, that's fine. Right, so get you this guy and that guy. Think about looking at the x and y plane from the side. Do you see that? Normally you're used to looking at it like this. You understand? Are you happy about that?
Yes, sir. Yes,
You've got that one, huh? Great, chief. Just give me a second. My Zeta is now just not in the line of where I wanted to be. So what happens now? We've got a new one here, right? A Z. You see Z there? There's Z.
Yes, sir.
Obviously, yeah. Okay. So I just want to remove this guy quickly, and then you can see your Z nicely. So Z is over here. So obviously that's positive, right? That's negative. You're aware of that?
Yes,
positive and it's negative, right? The same way here, this one here is positive and that one here is negative. You see? So we're plotting some point, like I'm saying this point over here, I'm putting this point here. It's a three-dimensional point, if we think about it. Some three-dimensional point. You see? If I'm going to put this here, right? This is, you can see where this is like in a positive, or depending obviously where this thing is, man. But in this case here, let me just zoom this in again. Here we've got 2, right?
Yes.
It's 2 away from this. It'll show you there, and then it's 2 away from that there. But the member goes all the way. It starts over there essentially, and therefore you can see that line over there. You see there, -5.
Yes.
So it gives you that. If it was going the other way, like, and I mean that way, obviously all these colors will could confuse you. It would have been +5. So what I'm trying to say like that. It seems a bit confusing now, but you understand. Once we do, we'll do another example and another example. You'll see. Just bear with me here. You need to do it, man. It's not so tricky. Yeah.
Oh,
Okay.
Okay.
Yeah. I think it's sort of hard to just explain it properly without a blank quotation point. Okay, I want to move on with this.
Sorry, I just
So
missed something.
yeah. So with this now we can compute. Matthew, you're speaking there. Okay,
Yeah,
so you just
sorry,
continue
sorry.
now. Yeah. So
Sorry.
to compute our forces, what we have to basically do now is get the length of the member and times by tension coefficients. So to obtain your length is fairly easy. I'll just do it for the first one. So remember what I showed you in the three-dimensional thing. That's why I said look at the coordinates, right? So length is just going to be your coordinates all squared and of course rooted. So we've got 3 on the x, 1, and we've got 5. So that's 3 squared plus 1 squared plus 5 squared, right? Obviously the sign doesn't matter because once you skew it becomes a positive. And we multiply that by the tension coefficient. That's 20 over 23. Okay. Can someone give me the next length as well? Someone give me the next length. I think there's a question over there. Where is this? Oh, is it Akawa?
Yes, the next strength is 2 square plus 2 square
Yes. Beautiful, beautiful.
plus 5 square. Then you
Yeah,
multiply
root of
this with 30 over 23.
There we go. That's it. Thank you, guys. This is what I appreciate. Right. And the last one is going to be, what is this? FCD is
0
But-
squared plus 3
Yeah.
squared plus 5 squared.
Yep. Here we go. Is it the squared plus 3 squared plus 5 squared? Okay.
And times
And that's
minus
minus-
50 over 23. Minus 50
Fantastic.
over
So-
23.
50. That's 50.
Minus
I
50 over 23.
100%. Well noted. Okay. Right. So then we can get our answers. This will be 5.1. I'll tend to question now. Kilonewtons. Obviously, this will tell you a sense already. So that boy's intent, his intention, he's being pulled. This guy over here is being is also being pulled. Is also intention, and this one over here, which is carrying the most load, is being compressed. And how you get marks here is 1 year, 1 year, 1 year, 1 year, 1 year. You always get a mark for the magnitude and you always get a mark for the sense. And you get a mark here and a mark here and a mark here. So if I count this out, like I said, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. Okay.
So
Yeah. Yes. I think Mr. Kawa raised his hand first. Let me take his question. Yes, I will assist you now, Yonila. Akawa?
No, it's fine, sir. It's fine.
Okay. Mr. Kasser?
yeah, so your force BD is wrong there. It's not 20 over 23. It's 30 over 23.
Thank you. Thank you. Noted. Grandson?
So I don't understand why we use 5 as positive, whereas in the equation is negative.
What I'm saying, remember, it doesn't matter if you square positive or negative. You understand? What's minus 5 squared?
All right, okay.
Mr. Zam, you're just being lazy. But yeah, it's the same thing, obviously, right? So we can just call it 5. Is it okay? Yeah, okay. Are we happy with this? This is the bulk of your marks. All right. Are we all happy with this?
So why do we
Okay.
have that line?
And Elisa, are you missing which line?
The line from E,
E.
because it looks like it's
I'm
just
not
adding
sure.
confusion.
I'm not sure what the line is there actually. Like I'm looking at it now. I see like it looks like a member there, right? But if you look at it on your actual your one in your textbook, there's no line there. It could have been a F up there or something. I don't know why it's there. I'm looking at it now. So please ignore that line. Or maybe they I don't know, they may be finding like I'm seeing this 3 there. Nah, honestly, I can't find the reason. Maybe it looks like a right angle triangle. Maybe it's beyond me. Honestly, it's beyond me. Yeah, I honestly don't know. Yeah, Alex.
Yeah, so sorry, I think someone just recently asked, why are you using +5s and a +3? Is it just because that if you square a negative, it's going to be a positive anyway?
No, that's correct. Yeah, that's what I just said now to.
Oh, sorry.
That's cool. Good for two things to be repeated. Yeah. And maybe they use a different approach. Like, yeah, I guess I don't know. I'm looking at these now. Oh, flip! I see now. I'm looking at the textbook here. Oh well, not a big deal for us. Just ignore that. It's no need really. Normally you don't end up with more than 3 members, but I might throw in a spin ball somewhere along the line. Maybe it depends on how I feel, but I doubt 3 members is normally the standard. Because this question I tried to play around with, and you'll see now why. So I want to show you Nella. I'll use a calculator, but obviously it's not just based on that. So what we're going to do now, I just wanted to play around. So go back to your matrix, and then what you should do is see what happens when you change these values. So what happens if and I always love these add-on questions, right? So what happens if I have a force here of 30 and maybe a force here of 5? So what I normally do with my questions, and you'll probably see the next example, is that I will say, okay, now let's add more forces, and then let's see if it's going to fail. So just to recap for you, Nela, okay, so like I said, so now we have new forces now, and the new force is going to be, it's in the z direction, that's going to be a 5 kilonewton, right? And in our x direction, I've said I'm going a 30 in. Let's see how members behave now, right? Are we all there? So Nela, this is to show you, but obviously this is to. I always check when things fail. You know me. I like to see. Where is the load? And textbook is playing too safe. It's always giving you the nice answers. So let's see. All right. Okay. So I think it's going to share now. I think it should be there. Yeah. So I'm going mode. Equation 2, and then it's all the same values again. So it's -3. I didn't say we knew these 2, 0, and I think in my x direction I said a 30. And that's going to be 1 + 2 -3, and of course that was a 10. Then I think I had -5 here, -5, -5, and then another 5. Nila, do you see how we did that? Obviously, I'm assuming you have this Casio over here. And once we do that, we just go equal, and then we have new tension. I'm assuming you have this Casio. Who's Alex or Mike, please? Equal. Who's this now? Oh, Musa's Mike. People, your mic. Yes, Alex.
No, sir, I was trying to turn it off, sorry.
Okay, cool. Matthew.
Yeah, so if you always put the forces acting, the external forces acting on the strut as positive at the end there, or is there a time where you would put it as negative? Like
no, it's going to be negative.
Yes,
oh, I see.
You put the 30 going the one way. If you put it the opposite way, would you put that as a negative, or do you just say that
you're right.
It's an external force?
Yeah, no, you're right. So if it's going the other way, I think I messed up here. Let me just go back to obviously I'm like looking and switching between stuff. So if 30 is going the other way, that means it's going to become a negative, right? The side here. If that's going if that's the positive direction, we change it as a negative. Are you happy with that one there? And then with 5, thank you for that. I keep on, it's my bad. And obviously, if that is going negative, this should become a positive. So so that's perfectly fine. So this stays 5 here. Yeah. So that is just me mixing up. Sorry. Yeah. Thank you for bringing that up again. So your first tension coefficient is now your TAD. Your new one is 7.1, 3 or 4. The second one is going to be minus 4.3. And the last one is going to be minus 3.82. Obviously, you see that they've increased drastically. And yeah, and if you talked about the length, we could get very interesting answers. So you'll see in the next example. Let's just quickly see here. 3.82. Oh, 3.823. Let's go back again. Yeah. And that's minus. So you see what happened here? What I think is quite beautiful is that initially we had our X and Y members only in well, they were in tension. But check now. This is now a strut, and that also has become a strut now due to it being negative. Okay. So yeah, that should be fine. Okay. So guys, we're gonna what we're gonna do next is shit in the PDF should have been whiteboard. Where's my whiteboard now? My whiteboard's not open now. Okay. Let's show the tabs open here now. Yeah. Okay, so we've got new. So what we're gonna do next? We're gonna do the next example, but we're just gonna take a short break, just to clear, just clear your mind, and then we're gonna start on the next example. And then I'm gonna just basically it's the next example in the textbook, and then obviously I have something new I want to add on that. Let me just quickly see so this particular example. This example 2, yeah, it is okay, cool. Yeah. So in the next example, so this is obviously adequate for the textbook. We can do this. We've got 12 marks, but there's an S4 manager type question marks next. So let's come back at 10:02. It's like 15 minutes from now, and we'll do the next example. And then yeah, what time is the lecture for the subject in? I think it's 11:40, right? It's 11. Yeah, 11:40. Okay, cool. Yeah, so we will have enough time to finish up this chapter. Okay, guys, see you in the next. This is all for session 1, and then we basically start on the next lecture. Well, the next period, essentially, as I call it. Okay, guys, see you shortly. Stop recording here. Now record again for the next.